So under California bearing ratio test, so this test is particularly conducted to check the bearing strength of a subgrade soil. So whenever the soil is used for the construction of highways, or whenever the soil is used as a subgrade material, then this particular test, that is California bearing ratio test, CBR test, should be compulsory, should be conducted to know the bearing capacity of the soil. See why this test should be conducted. So the purpose of conducting this test, to check what the load can be taken by the soil. So different soil will be having the different particle size and different compaction characteristics. So higher the compaction value, okay, that particular soil will be always better to take maximum load. So this parameter of this any particular soil can be checked with the help of CBR test, that is the bearing capacity of soil. Bearing means load carrying capacity of the soil can be checked with the help of CBR test, that is California bearing ratio test. Okay, so under this California bearing ratio test, this is the test apparatus, that is California bearing ratio apparatus, it is CBR apparatus. In this CBR apparatus, see, you can easily see we have two dial gauges, one at the top and one at the bottom. This topmost dial gauge will give you the load applied by the instrument. This top dial gauge will give you the load applied by the instrument. See what happens here, the soaked sample will be kept, and this is a plunger from 50 mm diameter to 60. So it has a standard dimension of 50 mm diameter plunger. So this plunger, whenever the load is applied, it will start to penetrate in the soil. So let us consider this as the soil. It will start to penetrate in the soil. So when it starts to penetrate in the soil, what happens here, in this penetrometer dial gauge, the deflection will occur. The deflection will occur. See, this deflection will show you that what amount it is penetrated inside the soil. Okay, so up to the what amount it is penetrated inside the soil, this is measured by penetrometer. Okay, so combination of this load versus penetration will give you the CBR value. How we are going to get the CBR value then? See, we have the graphical representation, x versus y axis. Okay, this is abscissa and this is ordinate. Here we will take penetration value, that is 0, 1, 2, 3, 4 up to 10, 15. Till 15 we will take the penetration value on the x-axis. Here we will take the load in kg or Newton. So what happens, we will plot the graph in such a way that load versus penetration combination is plotted on the graph. So what happens here, at 2.5 mm we are going to take a curve, we are going to make a point, and we are going to move it to the ordinate. In the same fashion, at 5 mm it is moved upward and taken to the y axis. So here we will get the load in kg or Newton. Is it clear? Here we will get the load in kg or Newton. So what we are going to do, the respective load for the respective penetration is noted down, and what is the next task here? We have standard aggregate loading here. We have standard aggregate loading. So this standard aggregate loading, what we will do? So this standard aggregate loading we will consider with the help of aggregate, and see. So these are the standard values for 2.5 mm penetration. For 2.5 mm penetration, okay, so this is the standard load, that is 1370 kg, and for 5 mm penetration 2055 is the standard load from that particular aggregate. So we have now the soil value and we have the standard aggregate value. So when we can compare both of this, easily we will get the CBR value of that particular soil. So if you can take any material, but always this should be compared with the standard value, that is 1370 for 2.5 mm and 2055 for 5 mm. So why this value is considered? So throughout the world, this material is considered as the hardest aggregate material or the hardest road construction material than anyone. So only this hardest material is taken. With the help of this hardest material, other materials are correlated or compared. Okay, so what we are doing now, we have CBR penetration value for 2.5 mm and CBR penetration value for 5 mm for the particular subgrade soil we are having, and respectively we are having the load value. So that value is compared with this standard aggregate value, these two values. So for that we have the formula here. CBR is equals to load or a pressure sustained by the specimen at 2.5 or 5 mm penetration divided by load or the pressure sustained by the standard aggregates at the corresponding penetration level into 100. Means here the load value for 2.5 mm penetration for that subgrade soil is taken and the standard aggregate value is taken into 100 will give you the CBR value at 2.5 mm penetration. At 2.5 mm penetration it is going to give. Next one, CBR value at 5 mm penetration can be calculated with the help of CBR value load at 5 mm penetration for the subgrade soil divided by standard aggregate. These both are taken and standard CBR value is calculated. So what we are getting here? We are getting CBR value at 2.5 mm and CBR value at 5 mm. Okay, both the values are noted down, and after that, see, it is from IRC it is recommended that CBR at 2.5 mm should be always greater than CBR at 5 mm. Okay, so always CBR at 2.5 mm should be greater than that of CBR at 5 mm. So it should be noted like this. If not, repeat the test with the proper leveling of the specimen and proper calibration of the instrument. So with the help of this, we are going to get the CBR value for the different soil. See, the main advantage of this CBR test is it can be tested for any type of the material. See, plate load test is always and only done for soil subgrade or the soil material, but CBR test, it is done with soil, it is done with aggregate, it is done with all the hardest material, whatever is we are going to use it for the construction of the road. So this is the main advantage of the CBR test, and we are always coming out with the CBR value. So friends, this is about today's class. In this class we discussed about soil subgrade, the properties of the soil subgrade. We have came across with the minimum volume change, we have came across with the permanency of strength, we have came across with the many more characteristics, and after that we focused on HRB soil classification. First we have focused on MIT soil classification. There right from 2 mm to 0.0002 mm materials we are having, that is from sand to the clay materials. After that we focused on HRB soil classification, that is it is classified with Highway Research Board soil classification from A1 to A7. So from A1 to A3 it comes under coarser soil and the sand. From A4, A5, A6 and A7 it comes under final soil, that is silt and clay. After that we came across with CBR test. So this CBR test, it is always checked for soil subgrade, which is used for the base course for the one of the base course for the construction of highways. Okay, so at the last, the CBR at 2.5 mm should be always greater than that of CBR at 5 mm. So after studying this in today's class, all the topics whatever we covered, it comes under module number 3, lecture number 20, that the course outcome is 2 with the Bloom level of taxonomy 3, 4, 5. That is, we are applying some concept, we are analyzing. In the upcoming class we are going to analyze some problems and we are evaluating the answers. So friends, in the next class we will focus on the other concept. Till then, thank you. Hi friends, this is Professor Harsha Jadhav and I am going to deal with highway engineering with the subject code 18CV56. In today's class, that is under the module number 3 and lesson number 20, I'll discuss about pavement materials and subgrade soil. So before going to the today's concept, I would like to brief out about whatever we discussed in the last class. So in the last class, we focused on curves and types. In that curves, we discussed on horizontal curve, what are the types of horizontal curve, which is the ideal horizontal curve. So these all we discussed. Even we focused on the concept of superelevation, extra widening, in that mechanical widening and psychological widening. Both this mechanical widening and psychological widening combinedly gives you extra widening. See, this extra winding is provided across the horizontal curves just to counteract the vehicles and to make the vehicles for the safe turning. After that, we discussed about summit curve and valley curve. Even we discussed about the application of both of the summit and the valley curves. So at last, we focused on course outcome and Bloom level of taxonomy. So in today's class, we'll start up with a new module, that is pavement materials. Okay, so under this pavement materials as a subgrade soil, so first we will focus on the introduction of the subgrade soil. Subgrade soil is an integral part of a road pavement structure which directly receives the traffic load from the pavement layers. The subgrade soil and its properties are important in the design of pavement structure. The main function of subgrade is to sufficiently stabilize stability under the adverse climatic and loading conditions. Okay, so these are the main function of a subgrade soil, and we have few of the desirable properties of a subgrade soil. So if I can tell you briefly about the subgrade soil, it is a main base for the construction of the roads. The natural existing ground itself is acts as a subgrade soil. If the subgrade soil is weak, then overall pavement will be always weak. Stronger the subgrade, stronger will be the pavement and highly durable will be the pavement. So only even stronger the subgrade, the road can take maximum load even than the expected. So after studying the concept of subgrade soil, now we'll focus on the desirable properties of a subgrade soil. So this under the desirable properties of a subgrade soil always should have stability. Stability means it should have the capacity of taking the maximum load. Next, incompressibility. Incompressibility means after application of the load, so it should not compress too much, or after removal of the load, there should not be much volume change. Okay, next, permanency of strength. See, after application of the load, when it is compacted or the voids are removed properly, this soil, whatever it is compacted, or the whatever the subgrade soil it is compacted, it should take the maximum load. Means after taking the load, the bearing capacity of that particular soil should be always last longs. It should always last longs. Next, minimum change in the volume and stability under the adverse condition of weather and the ground. See, that only after the application of the load. See, in the expansive soil, that is the fine clay soil, black cotton soil, after application of load, there is the minimum change in the volume should takes place. If the maximum change in the volume takes place after the application and removal of the road, then that particular soil it is never utilized. Next, good drainage. The soil should give a very good drainage so that water should not retain on the surface of the soil and it should be always drained off. Next, easy of compaction. The soil material should be in such a position that it should be get compacted easily. Okay, so these are the important desirable properties of the subgrade. Next, soil classification. Soil classification is mainly based upon the grain size. So we have different grain size of the soil, right from 80 centimeter to we have less than 0.75 micron. Okay, so all this comes under soil category only. But in order to differentiate the soils, we have the three major categories of soil. They are as follows. One is gravel, sand, silt and clay. Okay, the gravel, sand, silt and clay, these are the basic classifications of the soil. Okay, so how these soils are classified? So in order to classify this soil, we have different methods. We have BIS method, we have TMIT soil classification, we have triangular soil classification, we have um, HRB soil classification, that is Highway Research Board classification. We have different soil classification. See, under this MIT soil classification, it is given like this: right from 2 mm to 0.002 mm, we have the soil classifications. So, from 2 mm it is sand, above 2 mm it is gravel. From after 0.06 mm to 0.002 mm it is silt, and after 0.002 mm it is clay. So in this fashion the soil is classified under BIS MIT soil classification. Okay, so next comes Highway Research Board soil classification. So what do you mean by Highway Research Board soil classification? It is a standard method to classify the soil only for the construction of highways. Okay, so we are classifying the soil for even for many other construction works, but HRB soil classification particularly maintained or fixed for soil classification only for the construction of highways. So only it is termed as HRB, Highway Research Board soil classification. See, under this soil classification, this is a very important concept. So under this soil classification, we have from A1 to A7 soil classification. We have from A1 to A7 soil classification. I want to just brief about this HRB soil classification. So listen carefully. We have A1 to A7 soil classification. In that A1, A2 and A3 soil classification comes under coarser soil and sandy soil, whereas A4, A5, A6 and A7 soil classification comes under finer soil, in that silt and clay content is always higher. So when we are going to consider soil for the particularly for the construction of highways, then A1 to A3 soil is considered as the best soil for the construction of highways. See, this A1 to A3 soil, it is measured with 75 micron. So whenever the soil sample is given, less than 35% of the soil sample should pass through 75 micron or 0.075 mm. Then only that particular soil comes under A1 to A3 soil categories. If a soil is passing more than 35% through 75 micron or 0.075 mm, then that particular soil comes under silt and clay soil. Okay, so these are the classification of soil using HRB soil classification. Even this A4 to A7 soil classification is basically measured with group index and liquid limit and plasticity index. See, these parameters are always considered to classify the soil right from A4 to A7. So based upon the liquid limit, the soils are categorized. Next comes California bearing ratio test. So this test is used to know the bearing capacity of the soil only for the construction of highways. So wherever the highway construction is going on, so it is must and should to go with the CBR test of that particular subgrade soil. So this testing is very simple. Just I'll brief out about this test. For more information, refer Kanna Justo Kadiyali textbook of highway engineering. Okay, highway engineering from Kanna Justo and Veera Raghavan. Okay, this is a standard textbook. So under this California bearing ratio test, soil sample is collected from the site, and that sample, about 5 kg of sample is taken, and that sample is made to pass through 20 mm sieve and retained on 4.75 mm sieve. Okay, I'll repeat again. Soil sample is taken and that is passed through 20 mm sieve and retained on 4.75 mm sieve. And this soil is taken in 5 kg, and this soil, if we are going for modified, if I have done with modified compaction test, then we need to go for 5 layers 56 blows. Then if we are going for standard compaction test, then we need to choose 3 layers 56 blows. So again I'll repeat, whatever the water content we are using to compact the soil is OMC, optimum moisture content, that we have got from compaction test. we have two different compaction tests. One is standard Proctor test, other one is modified Proctor test. See, in this standard Proctor test, okay, so always 3 layers 25 blows are given in the compaction test, and modified Proctor test 5 layers 25 blows are given. So whereas when we are going to conduct the CBR test, then if the soil is done with standard Proctor test, then that particular soil is taken for CBR test, and 3 layers 56 blows are given for CBR test. Okay, if not, then if we are choosing modified Proctor test material, or if the compaction method is modified Proctor test method, then we need to take that particular soil in California bearing ratio test. We need to consider 5 layers and 56 blows for compaction. Okay, after compacting, see, the collar is removed, and the surcharge weight is kept, and included with this surcharge weight, the overall soil sample is kept in the water for 4 days. After 4 days, the sample is removed and it is kept for an hour in the room temperature. Later, that sample is kept in the CBR machine, where the load versus penetration readings are taken, and at last the graph is plotted with load versus penetration, and the standard penetration at 2.5 mm and 5 mm are taken. Okay, the penetration at 2.5 mm and 5 mm are taken, and we have some standard load CBR value for the aggregate. So those standard load are for 2.5 mm penetration, the standard load is 1370 kg, and for 5 mm penetration for aggregate, the standard load is 2055 kg. So what we need to do in order to calculate the CBR value of a given soil sample, so 2.5 mm penetration load of that particular soil is taken in the numerator, and 2.5 mm penetration load for the standard aggregate 1370 is taken in the denominator. It is multiplied by 100, and whatever the value we are getting, that will be in terms of percentage. For both CBR at 2.5 mm and CBR at 5 mm, these both values are calculated, and always note that CBR at 2.5 mm value should be always greater than that of CBR at 5 mm. Okay, so like this, the CBR test is conducted, and how this test is conducted, see here, this is the sketch of a CBR instrument. So this upper dial gauge will give you the load, and lower dial gauge will give you the deformation, that is settlement. Here the sample will be there, load is applied here, settlement will be there, and this settlement is noted in this dial gauge, that is to measure the penetration. Here in the upper dial gauge, the load is measured. Here the load is measured. Okay, like this the graph is plotted, and always CBR at 2, that is CBR at 2.5 mm should be greater than that of 5 mm. Okay, so this is the concept of CBR test, and we have many more concepts to study in the upcoming classes. So friends, so in this concept, whatever we discussed in today's class, that is lecture number 20, that comes under course outcome 2 with the Bloom level of taxonomy 3, 4, 5. That is, we are applying the concept, we are analyzing, because we have problems here. Okay, and somewhere we are evaluating. Okay, so this is the meaning of Bloom level of taxonomy 3, 4 and 5. So friends, in next class we'll focus on the other concepts. Till then,